Learning objectives. At the end of this topic, you will be able to understand complementary and supplementary angles, identify adjacent angles, linear pair of angles, and vertically opposite angles. Define transversal. Identify the angles made by a transversal on non-parallel and parallel lines. Verify if a given pair of lines is parallel. Complementary angles. If the sum of the measures of two angles is 90 degrees, then the angles are called complementary angles. Let us consider the clock. The clock is showing the time 3 o'clock, 9 seconds. The angle between the minute hand and the hour's hand is 90 degrees. Seconds hand is standing in between them. The angles formed by seconds hand with hour's hand and minutes hand with the seconds hand are complementary to each other because the sum of the angles is equal to 90 degrees. Let us discuss another example. The angle formed by ray BD with the ray BC and the angle formed by ray BC with the ray AB are complementary to each other because sum of the angles is equal to 90 degrees. Supplementary angles. If the sum of the measures of the two angles is 180 degrees, then the angles are called supplementary angles. Consider the straight line AB. We have already learned that angle in a straight line is 180 degrees. If we divide the angles into two parts, that is angle A and angle B, angle A plus angle B is equal to 180 degrees. Therefore, we can say angle A and angle B are supplementary to each other. Let's consider the clock. The clock is showing the time 5 o'clock, 59 minutes, 55 seconds. The angle between the minute hand and the hour's hand is 180 degrees. Seconds hand is standing in between them. The angles formed by seconds hand with the hour's hand and minutes hand with the seconds hand are supplementary to each other because the sum of the angles is equal to 180 degrees. Let's consider another example. In this, the angle formed by ray BD with ray DC is 60 degrees. An angle formed by ray DC with ray AD is 120 degrees. These angles are supplementary to each other because sum of the angle is equal to 180 degrees. Adjacent angles. The angles which have a common vertex and a common arm but do not have a common interior point are said to be adjacent angles. For example, let us consider the figure. Here, O is the common vertex, OB is the common arm, and there are no common interior points. Therefore, angle BOA and angle BOC are adjacent angles. When you open a book, it looks like the above figure. In A and B, we find a pair of angles placed next to each other. They are adjacent angles. Look at the steering wheel of a car. In the center of the wheel, you find three angles being formed, lying next to each other. These angles are adjacent to each other. Linear pair. A linear pair is a pair of adjacent angles whose non-common sides are opposite rays. For example, in this diagram, angle 1, angle 2 are linear pair because BC is moving in right side direction and BA is moving in the left side direction. Here, angle 1 plus angle 2 is equal to 180 degrees. Consider a real-life example. One pen is standing on a pen stand. The angle formed by the side, right side to the pen, and the angle formed by the side, left side to the pen are called linear pairs. Vertically opposite angles. Vertically opposite angles are the angles opposite each other when the two lines cross. Consider the two lines are intersecting at one point. While intersecting, four angles can be formed. We name the angles as angle 1, angle 2, angle 3, and angle 4. Here, angle 1 and angle 3 are formed opposite to each other. Therefore, they are called vertically opposite angles. Again, angle 2 and angle 4 are formed opposite to each other. Therefore, they are also called vertically opposite angles. When two lines intersect each other, the vertically opposite angles are equal. Therefore, angle 1 equal to angle 3 and angle 2 is equal to angle 4. intersecting lines. If two lines are said to be intersecting lines, then they will meet at one point. The point is known as a point of intersection. In this example, AE is a line and DC is another line. These two lines meet at a point B. Therefore, they're called intersecting lines. B is the point of intersection. Transversal. A line that intersects two or more lines at distinct points is called a transversal. Consider the lines AB and CD. LM is a line intersecting AB and CD at two distinct points, O and P. Therefore, LM is called a transversal. Angles made by a transversal. Observe there are 8 angles that will be formed when the lines M and N cut by a transversal L. We can identify the angles as angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, angle 8. The interior angles are angle 3, angle 4, angle 5, and angle 6. The exterior angles are angle 1, angle 2, angle 7, angle 8. The pairs of corresponding angles are angles 1 and 5, angle 2 and angle 6, angle 3 and angle 7, angle 4 and angle 8. The pairs of alternate interior angles are angle 3 and angle 5, angle 4 and angle 6. The pairs of alternate exterior angles are angle 2 and angle 8, angle 1 and angle 7. The pairs of interior angles on the same side of the transversal are angle 4 and angle 5, angle 3 and angle 6. Transversal of parallel lines. If two parallel lines are cut by a transversal, each pair of corresponding angles are equal in measure. In the given picture, AB and CD are two parallel lines. EF is the transversal passing through these parallel lines. Angle 2 and angle 6 are corresponding angles. They are equal in measure. Angle 4 and angle 8 are corresponding angles. They are also equal in measure. Angle 1 and angle 5 are corresponding angles. They are also equal in measure. Angle 3 and angle 7 are also corresponding angles and they are equal in measure. If two parallel lines are cut by a transversal, each pair of alternate interior angles are equal. AB and CD are two parallel lines. EF is the transversal passing through these parallel lines. Angle 3 and angle 6 are alternate interior angles. They are equal in measure. Angle 4 and angle 5 are alternate interior angles. They are equal in measure. If two parallel lines are cut by a transversal, each pair of alternate exterior angles is equal. Angle 1 and angle 8 are alternate exterior angles. They are equal in measure. Angle 2 and angle 7 are alternate exterior angles. They are equal in measure. If two parallel lines are cut by a transversal, then each pair of interior angles on the same side of the transversal are supplementary. In this given picture, AB and CD are two parallel lines. EF is the transversal passing through these parallel lines. Angle 3 and angle 5 are interior angles on the same side of the transversal. Sum of these angles are supplementary. That is, angle 3 plus angle 5 is equal to 180 degree. Angle 4 and angle 6 are interior angles on the same side of the transversal. Sum of these angles are supplementary. That is, angle 4 plus angle 6 is equal to 180 degree. Conditions for the lines to be parallel. If a transversal cuts two lines, the pairs of corresponding angles are equal and then the lines have to be parallel. In the first diagram, L, M are the two lines and N is the transversal intersecting the lines and makes corresponding angles A and B. If these corresponding angles are equal, we can say the line L is parallel to the line M. If a transversal cuts two lines such that pairs of alternate interior angles are equal, then the lines have to be parallel. In the second diagram, L, M are the two lines. N is the transversal intersecting the lines and makes alternate angles X and Y. If these alternate angles are equal, we can say line L is parallel to the line M. If a transversal cuts two lines such that pairs of alternate interior angles are equal, then the lines have to be parallel. In the third diagram, LM are the two lines and N is the transversal intersecting the lines, and makes pair of interior angles on the same side of the transversal are supplementary. Then we can say line L is parallel to line M. Find the complement of angle 40 degree. The complement of 40 degrees is equal to 90 degree minus 40 degree. We get complement of 40 degrees equal to 50 degree. Find the supplement of the angle 100 degree. The supplement of 100 degree is equal to 180 degree minus 100 degree. That is, the supplement of 100 degree is equal to 80 degree. Find the value of x, y and z in the given figure. The value of x is equal to 55 degree because vertically opposite angles are equal. Consider the angles x and z. X plus z is equal to 180 degree because the sum of the linear pair of an angle is equal to 180 degree. Hence, 55 degree plus z is equal to 180 degree. Therefore, z is equal to 180 degree minus 55 degree. That is, z is equal to 125 degree. Here y is equal to z because y and z are vertically opposite angles. Therefore, y is equal to 125 degree. Find the value of x in the given figure. From the given figure, we can write 32 degree plus x degree plus 43 degree plus 23 degree is equal to 180 degree because the sum of the angles in a straight line is 180 degree. Adding all the numerical values, we get 98 degree plus x degree is equal to 180 degree. Therefore, x degree is equal to 180 degree minus 98 degree. Hence, x is equal to 82 degree. Find the value of x, y in the following figure. Consider the angle y. Here the angle y is equal to 130 degree because vertically opposite angles are equal in measure. By observing x and y, angle x is equal to angle y because corresponding angles are equal in measure. Summary. Let's summarize the topic. Two straight lines are said to be parallel to each other if they do not intersect at any point. A straight line intersects two or more lines at distinct points is called a transversal to the given line. When two parallel lines are cut by a transversal, 1. Each pair of corresponding angles are equal. Each pair of alternate angles are equal. 3. Each pair of interior angles on the same side of the transversal is supplementary.